The universe is vast and beautiful. It is filled with countless stars, planets, and galaxies. We often look up at the night sky and feel a sense of wonder. We see the soft glow of the Milky Way. We see distant galaxies as faint smudges of light. It all seems so peaceful, so quiet. But this calm appearance hides a secret. The universe is not always a gentle place. It is full of immense power and sometimes incredible violence. Out there, in the deepest, darkest corners of space, there are forces at play that are almost beyond our imagination. These forces can shape entire galaxies and decide the fate of worlds. Imagine a beam of energy so immense it could stretch across 100,000 light-years. A ray so potent it could sweep through a galaxy and sterilize every planet in its path. This is not science fiction. This is a real phenomenon that astronomers are studying right now. These are the great cosmic death rays, born from the most energetic objects in the universe. These colossal beams of energy are called quasar jets. They are fired from the hearts of young, active galaxies. They travel at nearly the speed of light, carrying more energy than 1 billion suns. When one of these jets strikes a planet, it could strip away its atmosphere in an instant. It could boil its oceans and burn its surface to a cinder. The name quasar is short for quasi-stellar radio source. When they were first discovered in the 1950s and 60s, astronomers didn't know what they were. They looked like faint single stars through a telescope, but they were also emitting powerful radio waves, which stars don't normally do. They were a complete mystery. The breakthrough came in 1963. An astronomer named Martin Schmidt was studying the light from a quasar called 3C273. He realized that these lines were actually familiar patterns from hydrogen gas, but they were shifted dramatically towards the red end of the spectrum. This discovery was staggering. So what could possibly create that much light? The answer lies with the most extreme objects we know of, supermassive black holes. These are monsters. As gas and dust spiral into the black hole, they form a vast flat structure called an accretion disk. The friction between the particles heats the disk up to millions of degrees. The intense magnetic fields and extreme conditions create something even more spectacular. They can take some of the infalling matter and accelerate it to nearly the speed of light. This material is then channeled into 2 narrow beams, or jets, that shoot out from the poles of the black hole. These are the quasar death rays. The jets from a quasar are a river of this superheated, electrified plasma, all moving together in a single direction at nearly the speed of light. It is a cosmic thunderbolt of epic proportions. This river of plasma carries immense energy. The jet holds together over vast distances, sometimes stretching for lengths far greater than the diameter of their own galaxy. One of the most dramatic cases involves a galaxy known as 3C321. The powerful jet launched from the larger galaxy's black hole is aimed directly at its smaller companion. The jet is carving a cavity into the smaller galaxy, blowing its gas and dust out into space. It's like watching a cosmic hurricane tear through a city of stars. For any potential life in this unfortunate galaxy, the consequences would be devastating. Its atmosphere would be stripped away into space, its oceans boiled off, and its surface scorched by the extreme energy. The jet disrupts the entire galactic ecosystem, triggering bursts of star formation in some places and shutting it down in others. The stable, long-term conditions needed for life would be completely shattered. Astronomers have long been puzzled by a certain class of galaxies known as red and dead. These are massive elliptical galaxies that show almost no signs of new star formation. The jets and powerful radiation from the quasar would have acted like a giant cosmic leaf blower, heating up the galaxy's gas and blowing it out into intergalactic space. What if the quasar is not just a destroyer? What if it is less like a cosmic death ray and more like a cosmic gardener? A gardener must also prune and clear the ground. One remarkable example is a galaxy known as Minkowski's object. The jet appears to be crashing into a cloud of intergalactic gas and has triggered a massive wave of star formation. The shockwave could increase the density of the gas, pushing it over the critical threshold for gravitational collapse. The result? A sudden, brilliant burst of new star formation. In this scenario, the quasar is not stopping star birth, but actively igniting it. It is acting like a cosmic plow, turning over the galactic soil and sparking a fresh generation of stars and planets into existence. So we are left with a beautiful paradox. The most powerful destructive forces in the universe may also be a key source of creation. This dual nature is a common theme in the cosmos. The supernovae that mark the violent death of massive stars are also the source of the heavy elements, like the iron in our blood, that are essential for life. Perhaps life is most likely to arise in galaxies like our own Milky Way, whose central black hole, Sagittarius A, has been relatively quiet for billions of years. Our existence on Earth may depend on the long and peaceful slumber of the monster at our galaxy's heart. We live on a tiny planet orbiting a single average star in a quiet suburb of a galaxy whose own central monster is thankfully dormant. Our search for life elsewhere in the universe is therefore reframed. We must look not only for planets with water and warmth, but for galaxies that have achieved this same state of peace. The search for life becomes a search for other quiet corners of the universe, other places where the monsters have fallen silent. The story of the Quasar is a story of cosmic evolution. It tells us that galaxies, like people, have a turbulent youth before they settle down. It is in these quiet, mature galaxies that life may finally have its chance. The final frontier is not just about space, but about time, and understanding the violent history of the cosmos is the key to finding where life might have its future. The star that wasn't a star ended up illuminating our own origins.